Hello everyone, I'd like to welcome you to this video titled Simplifying Algebraic Expressions, and I want you to open up your math book and turn to page 19, and let's get out a pencil. So first of all, we're going to take a look at the objectives for today's lesson. First of all is to simplify algebraic expressions in one variable, and then also recognize that simplified and original expressions are equivalent. So there's a couple different terms there on the right, and one that you may not understand is called coefficient. I know we've talked about coefficients throughout this module so far, or throughout chapter 7. So we can see at the very bottom here, in the term 2a, 2 is called the coefficient of a. So what a coefficient is, it's the numerical factor in a term of an algebraic expression. So we can see the term 2a, 2, numerical factor, is the coefficient of a. So whenever we talk about coefficient, that's what we're talking about there. Something else we're going to explore throughout this video are called like terms and unlike terms. Okay, so we can see that a like term, terms that have the same variables with the same corresponding exponents. Okay, so we'll be able to take a look at this. For example, a and 2a would be considered a like term there. Okay, we can think about unlike terms. 2a and 3 would be an unlike term. Even though there's whole numbers that we're looking at, 3 has to have the variable of a next to it in order for it to be a like term, or the 2 cannot be a coefficient, just has to be a 2 there for 2 and 3 to be a like term. And we'll explore this as we go through this lesson as well. So even exploring this a little bit more, for number 3 on page 20, it says simplify a and plus 2a. So we can see a plus 2a and 3a would be what's called an equivalent expression, because they are all equal for values of a. Okay, so we're combining these terms. These are like terms, so we can combine them because they both have the variable a with them. So we can combine it. So a plus 2a is an equivalent expression to 3a. Okay, so remember, whenever we're taking a look at these equations, the left side and the right side have to equal, and these two do equal. And then also we know that a and 2a are the terms of the expression a plus 2a, and we can also see that a and 2a are called like terms, like I just said, with the fact that they both have a for the variable. Okay, understanding that whenever a variable is all by itself, it represents 1a or 1 whatever the variable would be. So let's take a look at the bottom of page 20. We're just going to simplify each expression so we can see b. So we think about it as 1b, 2b, 3b, 4b, 5b, and this is going to be 6b. Okay? Again, whenever a variable is all by itself, it's understood that a 1 is in front of it. Next one, we have x plus 3x. We can combine these terms because x is the variable for both. If it was 3x to the power 2, they would not be like terms. Okay? However, it's just x plus 3x, and that's going to give us 4x. Next one, 3y plus 6y is going to give us 9y. You can see the only thing that's changing is just the coefficient here. That's it. The variable stays the same. It's not like it's y to the power of 2 now. It's just 9y. Again, let's take a look at number 4. 4c, 2c, 5c. Add all the coefficients together. 4, 2, and 5 is going to give you 11. And the variable stays with that. It's 11c. Now what we're going to do, we're going to simplify algebraic expressions involving subtraction. Okay, so same idea of what we just did. We're just subtracting the expressions, or the terms, I should say. So let's take a look at the bottom of page 21. So now we have 5p minus p. All right, so again, understand whenever a variable is all by itself, 1 is understood to be in front of the variable. So we just think about 5 minus 1 is going to give us 4. Then again, variable stays there. 10x minus 6x, you just subtract the coefficients. 10 minus 6 is 4, and the variable stays the same. Again, the only way that we can simplify these is because they are like terms. 10x and 6x both have, or 10 and 6 both have x as their variable, so that's why we can combine them. Next one, we have 8y minus 3y minus 5y, so 8 minus 3 is 5. 5 minus 5 is 0, so that's just going to be 0. It would not be 0y, it's just 0 there. Next one, 12z minus 6z minus z. So we have 12 minus 6 is 6, minus z is going to be 5, and again, the variable stays the same, or variable stays the same there. The only thing you're dealing with are the coefficients. So 5z would be simplifying that algebraic expression. So what we could say for these algebraic expressions, 5p minus p equals 4p. So that would make them equivalent. 10x minus 6x is 4x. So they would be equivalent. So the left side and the right side of the equation are equal. This would equal 0. So again, left and right side would be equal there. So it would be 5z. Left side of my equation, right side of my equation both equal each other. Now if I were to do 6z, for example, that means this would not be equivalent, because the left side and the right side of that equation would not equal itself. Now we're going to take a look at practicing simplifying algebraic expressions using order of operations. Okay, now it's important to understand that when adding and subtracting algebraic terms without brackets or anything like that, it's important to work from left to right if you have addition and subtraction in the same equation there, and there are not any brackets or parentheses or anything like that. Okay, so it is important to also understand that you can only combine like terms. Okay, so whenever you're simplifying expressions, you can only combine like terms, and we'll take a look at this together. Okay, and what I like to do whenever I'm combining like terms is I like to box everything in and understand that terms are separated by the plus or minus sign here. So I'm going to box everything in here. I know I'm kind of limited on space. That helps me see the like terms and how they can be combined here. So what I have here is 2x plus 3x. That's going to give me 5x minus 4x. So we can see for this one, that is just going to be x for number 1. We're not going to write 1x down. It's just going to be x. Taking a look at number 2 here. Make this a little bit bigger. I'm going to box everything in so I can combine my terms very easily now. Okay, these are all like terms because they have the variable x next to the coefficients here. Okay, so we have 1x plus 5x, that's going to give me 6x. 6x minus 6x is just going to give me 0. Okay, again, we're not going to write 0x or anything like that. We're just writing 0 there. All right, let's take a look at number 3. So the first thing I like to do is separate my terms. I'll just box everything in here. Remember, the terms are separated by the plus or minus sign. Okay, now we got to combine like terms. Understand that not every term here is a like term. So b and b are considered like terms. Okay, so if we add positive b and positive b, that's going to give me 2b. So that's a like term, that's a like term. Now we can see positive 6 and positive 5 is going to give me positive 11 there. Okay, so this is the first one where we did not combine everything. They have to be like terms in order to be combined. If you ever see just numbers by themselves, okay, then you can combine those numbers with other numbers that are just by themselves. If you ever see the variable, understand you have to have the same variable attached to the number, or it has to just be a whole number like we can see with 6 and 5 there. Let's take a look at number 4 now. So again, boxing everything in helps us out here. And it's good to include the plus or minus sign so you can focus in on what you need to do. So 3b plus 4b, we can see a 7b plus 2 and 6 is going to give us positive 8 there. So we have 7b plus 8 is to simplify this algebraic expression. And why did we not combine the 2 and the 6 to the 3b and 4b? Because it's an unlike term. And remember, unlike terms will have different variables. Okay, so we can see 3b and 4b have the variable of b, and 2 and 6 just don't have the variable of b at all. Okay, so those would be considered unlike terms, so we do not combine those terms with each other. So this concludes the video on simplifying algebraic expressions. So we looked at simplifying algebraic expressions in one variable, and then also recognizing that the simplified and the original expression are equivalent. Remember to have, in order to have an equivalent expression, the left side of the equation and the right side of the equation need to equal each other. So please let me know if you have any concepts as you begin working through simplifying algebraic expressions.